All right, Algebra 2, we're going to go ahead and start Unit 3.1. I'm breaking this lesson up into two parts. So you'll do the first part today and then the second part the next day. All right, so we're going to be looking at graphing quadratic functions. We already started graphing with transformations, so a lot of stuff's going to be similar. All right, so our quadratic, we want to remember, has this U shape. And so you can see from this picture, we have lots of different parts that we can talk about on a quadratic graph. We have this axis of symmetry line that cuts the graph in half vertically. Let's see, we have a y-intercept. So you can see where it crosses the y-axis. We have x-intercepts where it crosses the x-axis. We have the vertex point, so that's either going to be the lowest or the highest point. Again, we call that a relative max or min, and it's also going to be the absolute max or min on these graphs. And we can find another point using the y-intercept and the axis of symmetry to reflect that point across the line. Okay. So general facts about a quadratic function. Quadratic functions create a graph called the parabola. And that's a U shape. Okay, so again, that's familiar to you. The standard form for a quadratic equation is ax squared plus bx plus c. You can write it as a function, f of x, or sometimes they also write it just as an equation with y instead, but it means the same thing. All right, so you can see from our diagram, we have some information that we want to be able to talk about. So the axis of symmetry, that's our vertical line that's going to cut the parabola in half. We have our vertex point. It's either a maximum point or a minimum point on the graph. We have x-intercepts where the graph crosses the x-axis. And later on, we're going to call those the solutions to the equation. But right now, since we're just talking about graphing, those are called the x-intercepts. Then we have a y-intercept, again, where it crosses the y-axis. The domain, again, if you look at the graph, it's all the vertical lines that intersect the graph from left to right. And on these quadratic graphs, the domain's always going to end up being negative infinity to positive infinity, always. And then the range, it's all the y values. Again, to find the range, we're going to look at what horizontal lines intersect the graph as we move from bottom to top. All right, so looking at these graphs, let's go ahead and answer each of these questions. All right, so on this first one, we can see the equation y equals it's positive x squared minus 4x. Now, because it's a positive number in front, a is positive, the graph's going to open up. Our axis of symmetry line is going to be the line that cuts the graph in half. All right, and so this is where it's located. And so where it crosses the x-axis, since this is a vertical line, we're going to say it's x equals, and then where it's crossing the x-axis would be 2. Right, so axis of symmetry, it's always x equals, and then where it's crossing the x-axis. Vertex, so that's going to be our lowest point or the highest point on the graph. And so we can see on this graph it's located right here. And that axis of symmetry line will cut through that point also. So the vertex point on this graph will be 2, comma, looks like negative 4. All right, and so we want to write it as a point, an ordered pair. And then we can also determine if this point is a maximum point or a minimum point. And we can see that it's the lowest point, and so we call that minimum. All right, and then we look at the second graph, y equals negative x squared plus 4x is the equation, and the graph is shown. We can see that because we're leading off with a negative number, a is negative, it does an x-axis reflection, and so it would be pointing down. Okay, again, our axis of symmetry line is going to cut through the vertex, okay, right in the middle. And we can say the axis of symmetry line, again, would be x equals 2. And then our vertex point is our highest point, and that looks like 2 comma 4. Again, we want to write it as an ordered pair, 2 comma 4. And since that is the highest point, we call that a maximum point. All right, so again, our standard form for the equation of a quadratic equation, y equals ax squared plus bx plus c. All right, so we're going to go ahead and graph this equation, y equals x squared minus 4x minus 5. So to find the axis of symmetry line, we're going to use this formula, x equals negative b over 2a. All right, and so using our equation, y equals x squared minus 4x minus 5, we can state what a, b, and c is from this equation. So a is the number in front of the x squared, and so in this case it would be positive 1. Again, there's a 1 in front. B is the number in front of just the x, so it would be negative 4. And then c is the constant term at the end, and that would be negative 5. All right, so when we want to find the axis of symmetry, when the equation's in standard form, we want to use this formula. Again, x equals negative b over 2a. All right, so all right, x equals, now we're going to plug in negative 4 for b and 1 for a. Okay, so it's going to be negative 4 divided by 2 times a, which is 1. So we're going to simplify this down. So that's going to be positive 4 over 2. And that fraction will simplify to 2. So our axis of symmetry line is x equals 2. All right, now when we want to find the vertex point, okay, it's always going to be, again, an ordered pair. We're going to take the axis symmetry number that we just found, and we are going to put it in for the x position of the ordered pair. All right, so the axis of symmetry line number is also the x coordinate of the vertex. All right, so now we got to find the y coordinate. So what we're going to do is go back to our equation. Okay, y equals x squared minus 4x minus 5, and you're going to substitute 2 in for all the x's. Okay. So y equals 2 squared, use parentheses, minus 4 times 2 minus 5. All right, so again, we just put 2 in for all the x's, and now we're going to simplify this. So order of operations, so this would be 4 minus 8 minus 5, and then 4 minus 8 is negative 4, and then negative 4 minus 5 is negative 9. All right, so the y coordinate of the vertex is negative 9. All right, so we have our axis of symmetry, x equals 2, vertex 2, negative 9. Now, based off the a value, which is positive 1, we know that the graph is going to point up. All right, if it was negative, it would do an x-axis reflection and it would point down. All right, so let's go ahead and start plotting what we have so far. So let's put in our axis of symmetry line, x equals 2. And so typically we just do a dotted line. All right, our vertex 2, negative 9. So let's plot that, positive 2, and then down to negative 9. All right. Now the graph is going to open up, and now we can use the a value, which is positive 1, to find 2 more points. And so you want to think of this as rise over run. So we can go up 1, left 1, and up 1, right 1 from our vertex. Okay. Step 5, find the y-intercept. So to find the y-intercept, what you're going to do is replace all the x's with 0 and solve for y. All right, so I can again show you. Here's our equation. We're going to plug in 0 for all the x's. So it's 0 squared minus 4 times 0 minus 5. Now, when you simplify this, what's going to happen is you're going to get negative 5. Well, negative 5 should be the c value, and that's what the y-intercept is always going to be. It's always going to be the constant term in the equation because you're replacing all the x's with 0. So the y-intercept is going to be negative 5. So on our y-axis, we can put a dot at negative 5. All right, so there it is. And now we're going to use symmetry to find another point on our graph. And so what you're going to do is count how far that y-intercept point is away from your axis of symmetry line. All right, and we can see that it's 2 units away. And so what we're going to do is count 2 units on the opposite side and put another point. And so that would be down here. And now with these 5 points, we can connect them. And we'll get a nice smooth curve. It's a U. Okay, so that's our parabola pointing up. All right. And so that's the basic idea behind graphing in standard form. All right, so let's go ahead and answer each of these questions. We're not going to graph 1 and 2. We're just going to answer each of these questions. All right, so given y equals x squared minus 10x minus 5, let's find the a, the b, and the c value. All right, so a would be 1, b is negative 10, c is negative 5. The direction of opening, since our a value is positive, it's going to open up. Our axis of symmetry line, we're going to use the formula x equals negative b over 2a. So we're going to plug those numbers in. So x equals negative 10 divided by 2 times 1. So that's 10 over 2, which is 5. All right. So again, we want to write the axis of symmetry as the equation of a line. So you're going to write x equals 5. All right, so x equals 5. Now we're going to find the vertex. All right, so the number that you found for the axis of symmetry is the x coordinate of your vertex. All right, so again, just put it right there in the x position. All right, so now we're going to find the y coordinate. All right, so you're going to take that 5 that we just found for x and replace all the x's with 5 in the original problem and solve for y. So y equals 5 squared minus 10 times 5 minus 5. Order of operations, 5 squared is 25 minus 50 minus 5. 25 minus 50 is negative 25 minus 5, so that's negative 30. All right, so our vertex is 5 comma negative 30. The y-intercept, again, you can find it by replacing all the x's with 0. And it should all come out to be the constant term at the end. And so that would be negative 5. So that's the c value. All right, so let's do number 2. Y equals negative 3x squared plus 12x plus 6. All right, so a is negative 3, b is 12, c is 6. All right, so the direction of opening is going to point down, and that's because a is negative. Okay, so it's negative 3, and because it's negative, that means it's doing an x-axis reflection pointing down now. All right, our axis of symmetry, again, we'll use the formula x equals negative b over 2a. So you want to memorize that. So x equals negative and then 12 over 2 times negative 3. So that's negative 12 over negative 6, which is positive 2. So the axis of symmetry will be x equals positive 2. Okay, right away you're going to put 2 in the x position of the vertex. Now you're going to substitute 2 in for all the x's in the original problem and solve for y to get the y coordinate. All right, so y equals negative 3 times 2 squared plus 12 times 2 plus 6. Order of operations, you have to do exponents first, then multiply by negative 3. So 2 squared is 4. 4 times negative 3 is negative 12. Then you can do 12 times 2, which is plus 24, and then plus 6. Okay, again, I'll just go left to right. Negative 12 plus 24 is positive 12, plus 6, and that's 18. All right. So our vertex is 2 comma 18. The y-intercept, again, you can replace all the x's with 0. And it's going to be the c term in the problem, and so c is 6. All right, so now let's go ahead and answer each of these questions, and then we'll do all the graphing also. All right, y equals x squared minus 6x minus 1. So our a value is 1, b is negative 6, c is negative 1. Our axis of symmetry, we're going to use x equals negative b over 2a. So negative, negative 6 over 2 times 1. So that's positive 6 over 2, which is 3. Again, write the equation of a line. X equals 3. Take the 3 and put it right in the x spot in the for the vertex. And now we're going to plug 3 in for all the x's, solve for y. Y equals 3 squared minus 6 times 3 minus 1. So that's 9 minus 18 minus 1. Negative 9 minus 1 is negative 10. All right, so our vertex is 3, negative 10. Our y-intercept, again, is the c value, which is negative 1. Let's go ahead and plot all this stuff that we have right now. Okay, our axis of symmetry, x equals positive 3. Let's put that dotted line, x equals positive 3. Okay, our vertex is going to be on that vertical line. Our vertex is at 3, negative 10. Positive 3, negative 10. We have our y-intercept of negative 1. All right, we can use symmetry from the y-intercept. Count how far that point is away. It looks like it's 3 points away, 3 units. So let's go 3 units on the opposite direction. So 1, 2, 3. That's going to put us right here at 6, negative 1. Let's use the a value to find 2 points from our vertex. So a is positive 1. So again, think of slope, rise over run. So from our vertex, we're going to go up 1, left 1, up 1, right 1. And we can connect those with our parabola. So you can see it. It's a U pointing up. All right, let's go ahead and give the domain and range for this graph also. So domain, again, if you go left to right, every vertical line is going to intersect this graph. So it's negative infinity to positive infinity. And the range, as you go from bottom to top, it's first going to hit at negative 10 with a bracket, and then go all the way to positive infinity. And let's go ahead and do 4. All right, so A is negative 2. B is positive 8. C is 1. Axis of symmetry, x equals negative b over 2a. So it's going to be negative 8 over 2 times negative 2. So negative 8 over negative 4, so that's positive 2. So let's write that as the equation of a line, x equals 2. All right, so then we can get our vertex. Take positive 2 and put it in the x position. And now take 2 and plug it in for all your x's, and then simplify like the y coordinate. All right, so y equals negative 2 times 2 squared plus 8 times 2 plus 1. All right, order of operations, 2 squared is 4. 4 times negative 2 is negative 8. 8 times positive 2 is plus 16, plus 1. And that should all simplify down to 9. All right, our y-intercept is the c value, which is positive 1. Let's go ahead and plot that right now. X equals 2 is our vertex, or the axis of symmetry line. Okay, our vertex is at 2, positive 9 this time. All right, our y-intercept is positive 1. Now we can use symmetry to get a point on the opposite side of the axis of symmetry. So it looks like it's 2 units away. So we'll count 2 units on the other side. Let's use the a value to find 2 more points. So our a value is -2. So that means we're going to go down 2, left and right 1. Okay. Oops, okay, went over too many. There we go. All right, and then we can connect those. This is a parabola, it's pointing down. Okay, we can give the domain, which is -infinity to +infinity. And then our range, it's first going to hit at -infinity, and then go all the way up to +9 with a bracket. All right, and then the last graphing, again, this is review. This is vertex form. It's just the name. This is what we used when we did transformations. If you want to use transformations to graph this, that's fine. But we can use a lot of the same stuff from standard form. All right, so our axis of symmetry is going to be the x equals again, but it's the opposite sign of the h value. Okay, so the h value is the number on the inside of the parentheses, and since it's inside, we do opposite. All right, and so we're going to go ahead and graph this equation, y equals 3 times x plus 2 squared minus 4. All right, so x plus 2 is on the inside, and we do the opposite sign, so it'd be -2. So our axis of symmetry line will be x equals -2. Vertex, you're going to take the opposite sign of what's inside the parentheses, which should be the same thing that you just wrote for the axis of symmetry, -2. And then the k value, the number on the outside, that's going to be your y coordinate, right? So -4. All right, so the vertex -2, -4. The direction of opening, again, is based off the a value, and since it's positive, +3, it's going to open up. If it was negative, it would open down. All right, so let's go ahead and graph what we have so far. Axis of symmetry, x equals -2. Our vertex is on that line. It's going to be at -2, -4. All right, again, we can use the a term to find 2 points. Again, we're using rise over run. All right, and so our a value is 3. So we're going to go up 3, left and right 1. So 1, 2, 3, left and right 1. All right, so the y-intercept. Here you're going to replace x with 0 and solve for y. So on this one, you actually have to plug 0 in because there's no shortcut, right? And then just do order of operations. So y equals 3 times 0 plus 2 squared minus 4. All right, so order of operations, inside parentheses first, then exponents, then multiplication, and then subtraction. So 0 plus 2 is 2, 2 squared is 4, 4 times 3 is 12, 12 minus 4 is 8. So the y-intercept is +8. So on our y-axis, we'll put a dot at +8. Then we're going to use symmetry to find another point. So it's 2 units away from the axis symmetry, so we'll go 2 units on the other side. And then we can just connect those points. All right. So do the best you can to try to make it look like a U. All right. And that should be it.